Welcome to Summarize Science, where we make complex research easy to understand. Today, we're looking at a breakthrough in robotics called MolmoAct2. The researchers behind this project wanted to solve a major problem. Most advanced robot brains are currently closed off or tied to incredibly expensive hardware. MolmoAct2 is a fully open-source action reasoning model designed for practical, real-world deployment. The goal here is to create a single generalist controller that can handle many different types of robots and environments. In the past, robots were often programmed for one specific task, but this new model can adapt to various chores out of the box. The image here shows the model working in different settings, like households, wet labs, and even cafes. It can perform complex maneuvers like cleaning up, washing dishes, and pouring tea without needing a custom program for each one. To make this work, the team focused on 5 major improvements over previous versions. They built a stronger backbone for the AI that is specialized for spatial reasoning, meaning it understands where objects are in 3D space. They also released several massive new datasets that help the robot learn from thousands of hours of human demonstrations. One of these datasets is the largest open bimanual dataset ever, which helps robots use 2 arms at once, just like a human. Accessibility was a major focus for this project. Instead of using robots that cost hundreds of thousands of dollars, the researchers showcased a setup using an IKEA table and affordable arms. The entire standardized setup shown here costs less than $6,000. This is a huge deal because it means more schools and independent researchers can experiment with high-level robotics. Technically, the model works by converting continuous physical movements into digital tokens that the AI can understand. It uses a specialized action expert that helps the robot decide the best way to move based on what its cameras are seeing. The system even looks at its own previous mistakes and successes to refine its future movements. This helps the robot maintain a high success rate even when things in the room are moved around. A particularly cool feature is called MolmoAct2 Think. Traditional robot brains often waste a lot of energy recalculating everything about a room every single second. MolmoAct2 Think uses adaptive depth reasoning to only repredict data for the specific parts of the scene that actually change between time steps. If a chair stays still while the robot moves a cup, the brain only spends its thinking power on the area around that cup. So, how does it compare to the most famous AI models in the world? In their studies, the researchers found that their model actually outperformed massive proprietary systems like GPT-5 and Gemini Robotics ER 1.5 across 13 different benchmarks. It was particularly good at tasks involving pointing and understanding the physical relationship between objects. This shows that a specialized open-source model can sometimes beat the biggest names in tech. In real-world tests, they fine-tuned the model for 8 specific tasks outside of a lab setting. This included things like preparing a pipette for a chemist, placing toys on a shelf, and even making popcorn. The model outperformed 4 other strong robot brains by a margin of about 15%. This proved that the model doesn't just work in simulations, but can handle the messiness of actual rooms. To recap, MolmoAct2 represents a huge step forward for open-source technology. By releasing the model weights, the training code, and the data, the researchers are giving everyone the tools to build better robots. In the future, this could mean that the robot helping you with your laundry is running on a brain developed by a global community of scientists. The era of truly smart, affordable, and open robots might be closer than we think. Thanks for watching Summarize Science.